you can do whatever you want when we're done with this. Okay, I'm gonna put on this face shield. Alrighty, so everyone step on up and grab a water molecule. That's what these are. These are water molecules. Do you guys know what do you know what molecules are?
Yes.
Okay, what molecules?
Particles.
Yeah, molecules are atoms. Atoms is the smallest of things. And so molecules are the combination of atoms to create something. So water is made up of 2 hydrogen and 1 oxygen atom. Together, looks like Mickey Mouse ears. If you ever look under a microscope at a water molecule, it looks like Mickey Mouse ears. Mickey Mouse's face and ears. So this is a water molecule, okay, at the smallest component. So now what I want you to do is I want you to take your water molecule and I want you to stick it against somebody else's water molecule, and then something besides a water molecule, like the table. And I want you to tell me which is stickier, water to water or water to something else. This is more stickier, or is this more stickier?
We weren't pressing it.
Well,
Give me that.
stick it against another tape.
Water to water. Water to water.
Water to water.
Let me see that.
Okay, so the water molecules, I got 2 water molecules. Okay, so 2 water molecules, they bind together with something that's called a cohesive bond. Like cohabitate, co-championship. People tie, they have the same score, similar. So co-adhesive, like molecules. So tape to a table, different molecules, that's called adhesive. Adhesive tape, adhesive bonding. So cohesive is stronger than adhesive. Okay, so that is one concept we want to have in mind. So now I'm going to take, and your name is? Ella. I'm going to have you do this demonstration. Have you ever watered a plant? Yeah. Okay, so I want you to water the grass. Okay, and I want you to observe what she's doing. What's happening to the water? Going out. Which direction is it going? Why is it going down?
Gravity.
Gravity. Gravity makes, what is gravity? A force pulls down. Yeah. So everything wants to get to the center of the earth. Okay, the earth is round. Wherever you're standing, we're held up by gravity. So the force of gravity causes the water to drop and go down. Okay. So now we're going to look at this sponge. We've got little Mr. Rubber Ducky in his pond here. This is a pond. Think this is a pond. Golf courses have ponds. So little Rubber Ducky's in his pond. Let's watch the water and the sponge. What's the water doing? What direction is it going? Well, how does it go up when gravity's making it go down? This doesn't seem right. What's happening?
No, they're focusing on the sponge. The water's going down because there's less water to hold it up.
Okay. So what did we just learn? Water molecules are sticking to each other. Okay. The adhesive bond, water to something else, water to sponge. There's a adhesive bond there. Adhesive bond is stronger. So this water molecule, the top of this, is touching the sponge, and it brings up its partner, and it goes after another sponge, another molecule on the sponge, and it keeps pulling it up, and then all of a sudden it stops. Why does it stop?
Because gravity is pulling it down.
Because gravity is pulling it down. So let's look at this another way about gravity and this water and this beautiful sponge. So we know that gravity wants water to go down. This movement going up is called capillary rise. It's about the water. All right. We're going to take this sponge here. Oh, what's happening here?
Water's
Okay, why is it dripping out of it? Gravity. Oh no, Ducky! There you go, you're happy now. Okay, so let's stop. And then we do this. Whoa, how come it's dropping now? It wasn't before.
because you changed the movement.
There's more water up here, so there's more gravity pushing here versus pushing here. So again, gravity is overcome, but why does this stop? Because the adhesive bond of that water holds it onto the sponge, tight to that sponge. That water is gripping that sponge until gravity overtakes it, and then it flows out. Okay, so let's look at one other little task here. Let's do this. Let's fill up this glass of water. Yeah, be careful not to take your hands off the table, because we're going to try to put a whole lot of water in this glass. Okay, can you see how that's...
Oh wow.
There's more water in that. There's more water in that. So how come I can put more water in that glass than the glass is full?
Because the water molecules stick together.
The water molecules stick together, form that bridge, and that tight bond around the outside, that adhesive bond is tighter than the water, so therefore it holds it up. So then I take some soap, and what happens to the water? It's starting to flow out. Okay? What did I do? What did the soap do to those bonds?
It separated the molecules.
It separated those molecules on the edge of the glass. Those adhesive bonds got broken down, and then that overspill of water cascaded over the top of the glass. So that concept of cohesive bonds and adhesive bonds is really, really important once we talk about water moving through soil. So whether we're using gravity here to overcome that force, or whether we're breaking the bond, those adhesive bonds, which are stronger, which is holding things together. So now we're going to talk about soils. So there are different sizes of soil. So what is this? This is a soil particle. It's just a big soil particle. What is this? Smaller rock, or a less bigger soil particle. Okay, what do you got here?
Very small soil particles.
This is gravel, we're getting smaller. Then we have sand, and we have silt, and we have clay. Okay, bigger, medium, real small. But if you took a microscope and you took one clay granule in a microscope, it would look just like this. Maybe a different shape, but it's got a form to it. There's just a whole lot of little ones. So when these go together, we're going to pretend these are clay molecules. They're stuck together. Okay, and then we pour water over them. Water's going to, what's going to stick the water to the soil?
Gravity?
No, gravity's going to make it go down. What's going to cause it to stick?
The bond between the molecules.
The adhesive bond, the water to the molecules. Have you ever gotten a walk? That rock is wet. It's not coming off. How come it's not coming off? Because the water molecule is adhesively bonded to that rock. It's stuck to that rock. Okay? And so it's stuck to the rock, and it's not flowing because it's held to the rock. So when we get wet, basically we get wet because water is stuck to our skin, and we take a towel and we wipe it off. We separate it. We use a towel to separate the water from our skin. So water is stuck to this by the covalent bonds. So now let's do a little experiment here with some sand, silt, and clay. So I need 3 volunteers. Anyone's name start with L? Name starts with L? M. Okay, we got
Last
one.
name starts with M.
What's that?
My last name starts
Oh, we'll go first then. E. E.
with
Oh,
No.
okay, let's
Both
see.
think you can do it.
There we go. You sure? Okay, you're so nice. Okay, you 3. 3 E's. I got you on the next one now. Okay, here we go. I'm going to come over here. We're going to pour water through sand, silt, and clay. So what do you think is going to happen when you pour water through these? What's going to happen to the water? It's going to make it muddy. Which way is the water going to go?
Down.
Okay, don't hold on to them yet because we're going to pour them at the same time. So you got to scoot over to make sure you have room all 3 of you are here. Okay, they're going to go down. Which one's going to go down faster, do you think?
Sand.
Why?
There's less particles, so there's first of all, it's easier for the water to navigate. Second of all, there's less to stick to.
Okay, that's the reason. There's less surface area. Who's got the middle one? All right, so pick your 1, 2, 3, pour them in, and let's watch the water flow. Okay, sand wins. What's in second place? Silt. It's a little bit bigger than clay, and this clay is really slow. And by Thanksgiving, that clay should be all the way to the bottom.
Maybe.
It's really slow. Because what's happening is we've got on our soil here, what we've got is this is really small. So there's the air spaces are really small, almost the size of a water molecule. So when 2 water molecules stick together, they're not going to let something pass it. Say gravity's going to take over, but then gravity's done. Now it's got to be driven down by some kind of a capillary rise. It's got to just find its way in amongst air spaces, but the air spaces are so tiny, there's no place for the water to go because the water is sticking to the soil.
Probably more like these rocks.
Yeah, so this would drain faster than that. This would drain faster, then this would obviously be really fast because there's lots of airspace in here. But these are just different sizes. So when we look at soil is made up of different sized particles. And when you mix it all together, like we've got some garden soil here, and you'll take garden soil apart over on that lab. You'll look at what's in garden soil. But I got 2 samples of garden soil, but I did something else. What do you notice about this one that it's not on this one? There's a sand layer in there. So we're gonna do, so we got a lady with the first name started with L. Was it L? M. M. And then pick a friend. You're gonna do the other water. Don't pick a friend. I'll say the letter, name starts with P. There we go. That was easy.
Name starts with
M and P. Okay, here we go. We got one.
That's it.
You get one. And you're gonna pour them over these 2 over here. Actually, we stay there. I'll move these down to you. Therefore, we don't have to go to. Okay, so what we've got is we've got garden soil. I'm gonna turn them around. So garden soil, and then there's a layer of sand in there. So what do you think is gonna happen with that sand layer? Any thoughts? And there's one. Let me get another cup.
I think it will go slow, and then it will go through the sand really fast, and then it will start slowing down again.
It'll go fast, slow, fast, slow. No. Slow, fast, slow.
Slow, fast, slow.
Okay, well, let's see. Okay, so I want you to pour that over the top at the same time, and then let's just watch it. Okay, it's going through the... Okay, watch this one. We're creeping down there. That one's cruising down into here. This one's hit the sand on this side.
And the sand might have mixed with the soil, so it passed through even faster.
So we've got, it hasn't gone past, we still got water waiting up here. The weight of the water is still pushing down, so we've still got gravity working on our side. Okay. And let's keep watching. Okay, so now we hit the sand. Let's add a little bit more water. No, you still got water on top, so you don't need that. There's that patience thing.
Yeah.
So you still got water sitting up on top, and it's not pushing it down. And this one here, again, you still got water. Which one is? Can you tell which one is deeper?
Sand. Well,
Yeah, this one's down to here. On this side, this one's turning around this way.
That one's starting to show.
It's starting to show on the, okay. So let's watch what happens down here. Let's add a little bit more water. Actually, we're gonna speed up this gravity process. So this is now accelerating on this side. Okay, and here we're still stuck up in the sand a little bit. So what happens with this sand layer? So you've got all kinds of particle sizes on the garden soil. So the garden soil goes down. And then what do we know about the sand? What do we know about the sand that's different than the clay? There's more airspace, okay? So as that water's going down, what did we learn about the glass overfilling the glass of water? As that water is traveling down, I'm going to get some gravel here. So we got gravel, we got a smaller particle over a bigger particle. Water flows through the smaller particle, and then it gets those big air spaces. It's those big air spaces, so it's like turning that glass upside down. That water doesn't want to leave its comfort zone because there's a big void there. So it's going to cohesively bond or adhesively bond to the rocks and doesn't want to hit the airspace. But what causes it to move through the soil?
Gravity.
Gravity. So it holds on to, because there's a big void in airspace, it will not move into the lower soil. So it's staying in that sand, and this is moving down through that soil. Because the air spaces that's in that sand, that's why it's bridged. So the whole purpose of that is when we build a golf course, we use a lot of water, okay, because we're growing a lot of things. When we build a golf green, this is about 12 inches. This is what the grass grows in. This is what we water, but we don't want to waste water, so we built what we call a choker layer. It's a 2-inch layer of sand. It's more like this material, because this has got even more airspace than sand does. So we build that in there, so when water goes down, it hits that layer and stops until there's a major rain event, and then we need that water to get off the surface, so when there's a lot of rain or excess irrigation and whatnot, it flushes, gravity overcomes that adhesive bond, and it flushes the water through the soil and then out the drain pipe. So when we engineer and we build a golf green, we design it with this choker layer in here so that we're saving water, so we're not just flushing all the way down to the bottom put a choke layer to stop the water until there's too much water, and then the gravity will take over and it'll flush all the way through. Make sense? Do you guys have any questions